Good morning, sir.
Hello, good morning, Kavi sir.
Good morning, madam.
गुड मॉर्निंग सर।
सर गुड मॉर्निंग।
आवाज ठीक आ रही है मैडम?
जी सर।
हाँ सर ठीक है।
तेज तो नहीं लग रही है?
नहीं ठीक है।
जी सर। अरविंद
हाँ,
सर।
लिंक आ गई? हाँ, अंकुश सर।
जी सर बस कॉपी कर लिया मैंने।
हाँ,
ताबी सर को कर देता हूँ।
तेजा मैडम आप सेंड कर रहे हो ग्रुप पे?
हाँ सर।
सर आप दोनों को मैंने कर दिया है। एक बार मैं देखता हूँ कुछ दिक्कत आ रही है।
सिस्टर ऐड नहीं हुई, सिस्टर फादर।
गैस से बात हो गई थी?
हाँ सर हो गई थी। 11:20 का बोले थे, करते होंगे ज्वाइन।
साउंड डिस्टरबेंस किस में से आ रहा है?
हेलो।
गेस्ट इज ज्वाइनिंग। हाँ
अच्छा, उसके बाद तेजा मैडम लिंक भेज दिया आपने?
मेरे पास लिंक आई नहीं अभी।
सर
मुझे भी
अरविंद सर
सेंड
मैंने
करूँ ना
आपको
लिंक?
ताबी सर को मैं डाल दूं क्या आपके ग्रुप पे वेबिनार वाले?
हाँ
गुड
ठीक है,
मॉर्निंग सर।
मैंने
अभी
सेंड
सर
कर
आप
दिया।
सेंड कर रहे हो?
Hello.
हेलो
Hi, good morning.
गुड
सर,
मॉर्निंग
गुड
सुमन
मॉर्निंग।
सर।
Good morning, everybody.
सर सम रिफ्लेक्शन इज कमिंग ऑन योर स्क्रीन।
Oh, reflection. Is it now visible? Or
ना
not?
यू आर विजिबल बट सम रिफ्लेक्शन इज आल्सो देयर। सम इमेज इज कमिंग एट फ्रंट ऑफ योर फोटो।
There should not be any image. I don't know.
ताबी सर,
Yes,
I'm
sir.
not seeing
oh,
any.
please send the link. Webinar group.
Yeah.
Space family, second year, third year.
अभी सर आप सब दूर सेंड कर रहे हो?
Yes, madam.
सिस्टर ज्वाइन नहीं हुई अभी? सिस्टर फादर?
नो दे हैव नॉट जॉइंड।
मैं सिस्टर को कॉल करूं क्या?
हाँ सर एक बार कर लो। सुमन सर कुछ प्रोजेक्टर जैसा इमेज आ रहा है।
ऐसा तो आना नहीं चाहिए। I
अभी
don't
सर
know.
आपको भी दिख रहा है क्या सर का इमेज में?
हाँ मैम, कुछ ब्लर, फोटो भी ब्लर हो रहा है।
Maybe it is because I don't know. There is a light on of my
Yes,
camera.
yes. हाँ लाइट आ रहा है सर।
मे बी एक मिनट में कोशिश करता हूँ, मैं अपना लाइट को ऑन करता हूँ तो ये शायद चले जाए। ठीक है ना, लेट मी चेक।
मैम दोनों ग्रुप पे डाल दिया है वेबिनार के, स्पिप्स ऑफिशियल पे, स्पिप्स फैमिली पे, बीएससी सेकेंड ईयर और थर्ड ईयर पे। और कहीं डालना है?
एनी इम्प्रूवमेंट?
मैंने सीएस थर्ड ईयर में भी डाल दिया है। जो पास आउट वाले हैं उनने भी कुछ ज्वाइन किया है।
Sir, your image is not properly clear. I think the background you have set, that's why it's making the problem.
Background, there should not be anything, no? I don't know.
some image is there background, but virtual image.
There is no virtual image as such.
We are seeing that one bridge over the
One
river.
bridge with a river.
Oh, I don't know. It should not be like this. 1 minute.
Tavi sir,
Yes, sir.
Tavi's sister is not joining. She is in another meeting.
Okay.
So welcome address. Okay, मैं बोल दूंगा, ठीक है?
Okay. Father आ रहे हैं क्या?
I don't
सर
know.
वीडियो प्ले करना है.
Yes.
11:25 हो गया.
11:25 हो गया है.
सर के एंड पे वर्चुअल बैकग्राउंड ऑन है.
ये
Yes,
कहाँ
yes.
से ऑफ करना है? That is I need to check.
Sir, actually in start video there is an option choose virtual background. If you are running with a PC, at the bottom of the panel, after mute button, start video, there is small icon.
Is it okay now?
Yes, now it's
Yes, sir. Yes, sir.
Yes,
Now
Okay,
it's okay.
fine. Somehow it was on. I don't.
I am playing the video now.
Okay, sir.
Sejal madam.
Yes, sir.
Yes. She is a sister is busy in another meeting.
Okay, I will call you.
Okay.
Okay.
Welcome.
Okay.
नमस्ते सदा वत्सले मातृभूमे महामंगले पुण्यभूमे त्वदर्थे पतत्येशकायो नमस्ते इमे सादरं त्वा नमामो वयम् त्वदीयाय कार्याय बद्धः कटीयम् शुभं आशिषं देहि तत्पूर्तये अजय्या च विश्वस्य देहि शक्तिम् सुशीलं जगद्येन नम्रं भवेत् श्रुतं चैव यत्कण्टकाकीर्णमार्गम् स्वयं स्वीकृतं नः सुगं कर्येत नमस्ते सदा वत्सले मातृभूमे महामंगले पुण्यभूमे त्वदर्थे पतत्येशकायो नमस्ते शक्तिं सुशीलं जगद्येन नम्रं भवेत् श्रुतं चैव यत्कण्टकाकीर्णमार्गम् स्वयं स्वीकृतं नः सुगन्कर्येत नमस्ते सदा वत्सले मातृभूमे महामङ्गले पुण्यभूमे त्वदर्थे पतत्येष कायो नमस्ते नमस्ते सादरं त्वा नमामो वयम्
Shall we start, sir?
Yes, yes.
A very warm good morning to Honorable Director, Reverend Father Simon Raj, respected Principal, Dr. Sister Alice Thomas, Head of Science Department, Dr. Arvind Jain, today's resource person, Professor Suman Mukhopadhyay, all esteemed faculty members, webinar participants, and dear students. I, Professor Shezal Gupta, welcome all of you in this national webinar, Metals in Healthcare. It is our immense pleasure that we have with us Professor Suman Mukhopadhyay to share his knowledge on the same. Before we start the session, let us invoke the God's blessing. Please be ready for prayer. Heavenly Father, we thank you for this provision that you have granted to each one of us gathered here today. Almighty God, we thank you for your protection during this time of pandemic, and we seek your blessings and healing hand on our Mother Earth. God, we pray for our director, principal, members of the institution, our guest speaker, and all the participants. May your guiding hand lead us all through this webinar. We commit all the proceedings into your holy hands and ask this prayer in Almighty name. Amen. Now, for the formal inaugural and welcome address, I request Head of the Science Department, Dr. Arvind Jain, sir. Sir, please.
Thank you, madam. A very good morning to one and all present here. On behalf of Department of Science, Central Institute of Professional Studies, Indore, I welcome you all for the national webinar on the topic Metals in Healthcare. First of all, I heartily welcome to our Director, Reverend Father Simon Raj. A very warm welcome to our Principal, Dr. Sister Alice Thomas. And I am very happy to welcome today's resource person, Professor Suman Mukhopadhyay, Discipline of Chemistry, IIT Indore. I also cordially welcome all my dear colleagues and participants. Thank you so much.
Thank you, sir. Now, I request Dr. Tabinandan Joshi for the brief introduction of our resource person. Please, sir.
Thank you, ma'am. Professor Suman Mukhopadhyay, Discipline of Chemistry, IIT Indore. Professor Suman, born in Kolkata, He has completed his BSc and MSc in chemistry from University of Kalyani, West Bengal. He has carried out his doctoral research in Indian Association for the Cultivation of Science, Kolkata, and obtained his PhD degree in synthetic inorganic chemistry from Indian Association for the Cultivation of Science, Jadavpur University, Kolkata, in 2004. After that, he joined in National University of Singapore as a postdoctoral fellow. In 2006, he moved to Lisbon as FCT postdoctoral fellow to join at Institute Superior Técnico in Portugal. In 2009, he moved to EPFL in Lausanne, Switzerland as a Marie Curie International Incoming Fellow. In 2010, he joined IIT Indore as an assistant professor. His research interests are organometallic compound in therapeutic and mechanism, bio-inspired catalysis, molecular recognition, metazoles, and applications. Currently, Sir is working as an associate professor in IIT Indore in the discipline of chemistry. We are fortunate that we have an eminent personality with us. Welcome, sir.
Thank you.
Thank you. Madam, unmute कीजिए. Unmute your mic.
Thank you, sir. Now, I request our resource person, Professor Suman Mukhopadhyay, to start the session. Please, sir.
Thank you very much for the kind introduction. And also, I must thank SPIPS Indore for inviting me for this national webinar. And I must also thank Principal Dr. Sister Alice Thomas and also Dr. Arvind Jain and also Madam Shejal Gupta for the invitation. In today we are going to, or I am going to present about metals in healthcare. So may I share my screen? Perhaps I need to. Okay. Let me try. Is it visible?
Yes, sir.
Okay. So as we know, and we are in a very difficult position in today's world. From last November 2019, the pandemic that has been originated in China, that has been taken over all over the world. And mankind is in a position where they have to really struggle how to make ourselves exist in a proper way in today's worlds. So this is really very, very uncertain situation. And also it is curious because humankind, we feel like that being man is a blessing and we are the topmost people in the, or what I should say, that we are the boss of this world, and we can really continue to dictate our terms in our own way. But now we are facing such a kind of crisis that we understand that really we are far from being it, and we need to really understand more that how to fight with these kind of problems. And we need more resources, more research, more understanding, so that in future also there are chances that we are going to face similar kind of problems, how to deal with that. So as all of you really quite aware about this COVID-19 crisis, and a lot of informations are already in the air and in the newspaper, in the media and everywhere regarding what a virus is and how to deal with that. One clear-cut indication is that among the whatever remedial we have so far, there are very little we can do about whenever a virus becomes very much contagious and very much problematic. And we are resorted to such kind of practice that we remain in our home, we practice the social distancing, and it is really creating a lot of trouble in our daily to daily activity, and economic downturn has been started. So we really don't know where we are going to and when this problem will be elevated. Now, as so many has been already talked about COVID-19 and the problems of virus, today I am not going to talk about this problem of how to come out of that problem of virus. Today I am going to talk about metals in healthcare. As an inorganic chemist and also to some extent interested about the biology, it is interesting to know that in our biological systems, metals take part in different ways, and they're really very much important to sustain our life by doing various biological processes inside our body. And also, these metals can be utilized to treat and diagnose certain um, illness inside our body. And we are going to focus on that today. And basically, first we need to know why metals are important for a biological system, or why it is absolutely essential. So to start with, I want to, as I know that the listeners, they are from various backgrounds. So just I want to start from very basics. And then towards the end, I would like to introduce a bit of research work all over the world, what is going on today's world, to make it more conducive environment for us to live in a happily manner in today's world. So if we just think about metals, and if we just close our eyes, if we are not a chemist, the first thing perhaps we can see is something like this. These are iron rods, we know very easily. These are available very cheap, and we require these for building, to build our buildings. Okay. And if we try to go further, thinking that what metals we are very much familiar with, we may see something like this. These are copper plates we use sometimes, particularly doing the religious rituals and all. And so we are quite familiar with this. And we try to think further, and we might see this. We all know about this also. This is a glass of milk, and whenever we are thinking about milk, we all know that it contains a lot of calcium, and that is also important very much for our body. We'll come to that, why it is so much important for our body in the later slides. Try to think about further. We might see some silver coins, we might see some gold biscuits, and we might see some platinum jewelry. So these are also important, not for our existence really, but to enrich our life in terms of how lavishly we can live. But in today's world, when the basic existence is in question, we try to find out that what are the metals which are very, very important for our existence. And if we look at the biology and also the chemistry and biochemistry, we'll see that biological system never accepts those precious metal which we utilize for making our jewelry or making gold biscuits. So these are, none of them are really in use for biological systems. Biological systems generally utilize much more cheaper metal ions which are available in plenty in our nature, like iron, like copper, like calcium. So really speaking, in terms of biological systems, these metal ions are far more important than those metal ions which we cherish generally, and which like to have in our kitty. So going to the next slide, this is about the Bible of a chemist. This is called periodic table of the elements, which has been first proposed by Mendeleev, a Russian scientist, and that has been further improved by many other scientists later on, and many more elements have been discovered over the years. And if you look at this particular periodic table of elements, you can see the several elements they have classified in certain periods and certain groups. And if you look at the groups, the left hand side, you can see a column. The far left, there is the column of the red colored elements. They are known as alkali metal ion. The second one, which are orange colored, basically the boxes are orange colored, they are called alkaline earth metal ion. And then you can see there are a lot of metal ions which are depicted in indigo boxes. These are transition metal ion. And as you go towards the right of the periodic table, you get elements like carbon, nitrogen, oxygen, fluorine, which are in the boxes which are of green colored ion. So basically, according to the properties of these elements, those are in the red box, those are in the orange boxes, and those are in the indigo boxes. They are basically metal ions. And in the right hand side, which are in the green boxes, they are basically non-metal ions. And there are certain basic differences in their properties. What are the metal ions and what are the non-metal ions? So if you try to find out what are the basic properties of the metal ion, and if we look at the physical properties of the metals, you can see generally metals like iron, like copper, they are ductile, they are malleable, they are good conductors of electricity, they are good conductors of heat, they are shiny, their melting point and boiling points are high generally, and they have high density, generally they are heavier than water, and their strength is high. So these are some basic physical properties of the metal ions or metals, and it is because a special kind of bonding that is there between the metal atoms when they exist in solid state, which is known as metallic bond. So first we need to know about a bit about the bonding. Perhaps you all know about this bonding, what is there in the chemistry, but we can just try to refresh our memory, and we can start with the structure of an atom. So generally we know that in an atom there is a nucleus which consists basically neutrons and protons, and in the outer orbits there are electrons. Most of the mass of whenever one particular element or atom of one particular element is making bond with an sodium chloride, and sodium is a metal ion and chloride sodium ion is a metal ion definitely, and chlorine is a non-metal. And whenever we are talking about how the bonding is happening, we assume that one of the electron from the outermost orbit of the sodium that gets shifted into chlorine, and thus sodium becomes cation and chlorine becomes anion, and they have some kind of electrostatic force of attraction existing between them, and they are making a lattice, and they are existing as a solid. And whenever such kind of electron transfer occurs from one metal center to one non-metal center, there is formation of the ionic bond. And if you look at how strong the bond is, you can see that generally the bond strength is something like from 600 to 4000 kilojoule per mole. So this is one kind of bonding what we can see in general metal salts. Now, as I was talking about, in general, the metals, they are solid. And why they are solid? As I said, the metals, they are generally having some outer sphere electron, which are not bound that strongly with their nucleus. So whenever we are considering a metallic solid, there are the nucleus which are positively charged, and there are the electrons in the outer sphere, and these electrons are freely moving throughout the whole metal body. And as the electrons are freely moving throughout the whole metallic body, there is no demarcation which electron really belongs to which nucleus. And that's why generally metals are conducting, because there are free electrons which can go from one end of the metal body to other end. And metallic bonds are also quite strong. And if you look at the energy, you can see it is about 90 to 900 kilojoule per mole. And there is another kind of bond which generally happens between non-metals when sharing of electron happens between two atoms of non-metals, and that shared are generally getting um, involved of both the atom involved in the bonding, and this electron pair is shared by both chlorine atom A and chlorine atom B to make a chlorine molecule. And these are called covalent bond, and generally the energy of the covalent bond is less, which is something like 150 to 400 kilojoule per mole. And that is why basically many times we see non-metals, they are gaseous in nature. Now, as we are going to talk about metals today, so we restrict our focus on the bonding basically of ionic bonding and metallic bonding. Now we try to think about some metallic salts. As I said, that metals are prone to give away electron to the non-metals, and non-metals are prone to accept those electrons in their outer electronic orbit. And in this way, they are generally forming a cation and an anion, and they are electrostatically getting attracted to each other, and they are forming bonds. So two very common salts where these things are happening we can find in our kitchen. One is sodium chloride, as I have already shown in my last slide how the bonding is happening, and the other is baking soda, and that is sodium bicarbonate, where also sodium ion is giving away one electron to the bicarbonate ion. It is forming bicarbonate ion, and then there is electrostatic force of attraction happening between them. And we also know that sodium chloride is essential almost for our survival, because both sodium ion and chloride ion has some kind of biological activity inside our body. And we'll see what kind of activities, particularly sodium, is doing inside our body, which are very much important for our sustaining life. Now, apart from this kind of bonding, that is forming a cation and forming an anion and making a ionic bond, metal ions have another kind of valency, which are told as secondary valency. The secondary valency means as metal ions, they love to exist as cation, giving away electrons. Then it can attract certain other molecules which have lone pair of electrons and which can be donated to the vacant orbitals of the metal ion, and in this way they can get ligated to the metal ion. The first picture you can see, this is a cobalt complex, cobalt hexachloro complex, where the cobalt ion is represented in pink color, and the chloride ions, you can see there are 6 chloride ions surrounding the cobalt center, and they are donating their lone pairs to the outer orbital of the cobalt, and thus they are getting ligated to the central cobalt ion, and thus it is making coordination bond with the central metal ion. So whenever there are such kind of ions or molecules which gets making their electron pair donated to the metal center, we call them ligand molecules. And these ligand molecules play a very, very important part in the chemistry of the metal ion. Now, whenever we are considering about the ligand molecules and it is getting attached to the metal center, it cannot get attached in any number or any geometry. There are certain rules to be followed. So generally, the number of ligand molecules getting attached to the central metal center, generally what we find is either it is 4, or it could be 5, or it could be 6. Now, if we look at your right hand side, there are two compounds. One is copper chloride complex and another is platinum complex. The copper chloride complex, there are 4 chloride ions attached to the copper center, and the particular structure of this particular complex is something like tetrahedral in nature, or you can consider something like pyramidal structure. Now you can see there are 4 chloride ions attached to the metal center. So the coordination number of the metal center is calculated as 4. Now, whenever there are 4 different ligands attached to the metal center, whether it will be always tetrahedral in nature? No, there are 2 possibilities. One is the first one, the copper complex, and second one is the next one, which is the platinum complex. And you can see the coordination number of platinum is here also 4, because 4 different moieties are attached to the platinum center. but the structure here is square planar. It is like a planar structure. It is not tetrahedral structure. And furthermore, if you go to the left hand side structure of the cobalt, you can see the coordination number is 6 and the structure is considered as octahedral. So what is the message from here? The message is something like that. Metals, they tend to give away electron, they want to become cation, and when they become cation, they attract surrounding molecules which are having some kind of lone pairs which can be donated to the empty orbital of the metal center, and those molecules which are getting attached to the metal center in such a way, they are termed as ligands. And ligands molecule, when getting attached to the metal center, generally the number of ligand molecule is 4, 5 or 6. It can be even as low as 2, 3 or more than 6, but generally we restrict our discussion here with the coordination number 4 to 6. That will be good enough for us for today's talk. Now, if we go to the next slide, as I said earlier, that if you look at the periodic table in biology, you can see in this particular table, which is called the periodic table for biologists. And you can see that certain boxes are colored with green, and these boxes represents those particular elements which you can find in our biological system. And if you look what are those elements, you can see like hydrogen, sodium, potassium, magnesium, calcium, manganese, iron, cobalt, nickel, copper, zinc, and of course carbon. Most of the organic material is composed of carbon and hydrogen, nitrogen, phosphorus, oxygen, sulfur, chlorine, and iodine. The rest of all the elements are not really useful for a biological system to exist, but we can make them useful in certain way to take care of our health, and I'll gradually go into that, how we can really activate or utilize some of these metals uh, for our healthcare system. Now, let us see what are the role of these metal ions. Whatever the periodic table you have seen for the biologist, there are certain metal ions which are really important for our body. If I just go back, you can see the metal ions which are mostly in the left hand side of the periodic table and which are important for our body is sodium, potassium, magnesium, calcium, manganese, iron, cobalt, nickel, copper, and zinc. So these are the metal ions which are very much important for uh, our biological processes. The first importance is that calcium is very much required. As I have shown the glass of milk, generally we used to tell the children to take milk because they were in generally in growing stage and they need to develop their skeletal system which should be hard enough to sustain our body. So we require skeletal system to sustain our body, and we also require teeth to chew our food, and both of them are basically made up of calcium phosphate. It is not only calcium composed of calcium and phosphate, but there are some hydroxide ions also. And remember what I said, that metal ions, here the calcium is in ionic form, they are in the +2 oxidation state, and they are ligated by these phosphate ions and hydroxide ions to make our basic strong structure, that is our skeletal system and our teeth. And what is important is that it is not like calcium sulfate, it is not like calcium chloride, it is not like calcium nitrate, but nature has chosen calcium phosphate, and there is a reason behind it. The reason is that all those salts, what I have said, that phosphate, apart from phosphate, that is sulfate, nitrate, chloride of calcium, all of them are water soluble. But we cannot have our basic structure strong enough if we use a water soluble salt, because we use water day in, day out in our food, in our drink. And if we have something like our basic structure will calcium sulfate and we drink a glass of water, everything will get dissolved and will not exist. So that's why nature has chosen an anion which makes a calcium phosphate system to give our skeletal or teeth, which remains, which helps us to give give a solid structure on which our body can rely on. Go to the next phase. Now, if you look at this picture, this is a picture taken from top of the earth, and whatever it signifies basically is nothing but atmosphere. We know that our earth is, there is an envelope of atmosphere surrounding our earth. And if you look at what are the main constituents of this atmosphere, you'll find that there are nitrogen, there are oxygen, there is carbon dioxide and some other gases, but mostly it is composed of nitrogen, oxygen and carbon dioxide. And interestingly, nature has utilized these gaseous molecules in various way for our life sustaining process. But there is one problem with that. The problem is that if you look at the structure of nitrogen, oxygen and carbon dioxide, you can see these are the molecular structure of them, and they are linear molecule. Diatomic molecules are always linear, like oxygen and nitrogen, definitely it will be linear because there are only 2 points to be joined with. Carbon dioxide is also a linear molecule, and moreover, as they are linear molecule, they are also non-polar in nature. All of them, oxygen, nitrogen, carbon dioxide, all of them are non-polar in nature. Now, if you considering the biological systems like our body, if you want to transport a non-polar molecule inside our body, then you require a non-polar medium. But if we just think what is the main transporting agency inside our body, delivering the food, delivering the gas, we will see it is blood. And what is the main component of the blood? It is water. And we all know that water is a polar molecule. So if we want the water molecule or the polar molecule or our blood to transport oxygen, to transport nitrogen, to transport carbon dioxide, it is not going to happen, because we know that non-polar molecule does not get dissolved in a polar molecule. So there is a problem how to activate these gaseous molecules, which are very much required in our life sustaining process. And why nature has chosen these molecules to be utilized in life sustaining process? It is because this is plenty of them are available in the atmosphere. There is no shortage of the resource. We can take plenty of oxygen, we can take plenty of nitrogen, we can take plenty of carbon dioxide, and it is easily available. But the problem with the nature was how to transport this molecule inside the body. So nature has developed certain systems to transport these molecules in our body. We know about oxygen, definitely that we require oxygen for the sustaining of our life, because we get energy by burning glucose. So these are two reactions I am representing, which are the most two important reactions happening in biological system. The first one is photosynthesis. You know about that. Photosynthesis does not happen in our body, it happens in plant kingdom. Generally, carbon dioxide get absorbed and it is reacted with water in presence of sunlight to give glucose and oxygen. And these glucose act as a source of energy in our body. Now you can see in this particular reaction, carbon dioxide has been utilized. And this carbon dioxide has been utilized by plants. And in even plants also, the main transporting system is water. So there must be some manageable particular transport agent which can transport these particular non-polar molecules inside the plant's body or in the human body or animal body. And if you look at the second reaction, that is the reverse reaction of the first reaction. That is, we are burning glucose, we are oxidizing glucose, and we are getting carbon dioxide and water. This is happening respiration every day, every 24/7 it is happening inside our body. And whenever we want to burn glucose, we require oxygen. Now, whenever we are inhaling nitrogen plus oxygen. Now, oxygen is to be included inside the blood. Nitrogen we don't require, that is to be thrown out from the lungs. So oxygen, how we can include oxygen inside our body? There must be some system which so that oxygen can diffuse in the blood, which is basically composed of water. So nature has developed a unique system which is called hemoglobin. Hemoglobin is a protein. If you look at the structure, this is a protein structure where there are 4 subunits and there are certain iron center inside it. You can see the red blood cells of our blood. They're composed of this hemoglobin, and in this hemoglobin there is an iron center. And this iron center, as I said, that they are in cationic state and they like to get electron pair from certain molecules which can donate the electron pair to the metal center and thus making a bond. And interestingly, the oxygen, it has some lone pair and it can get attached to the iron. You can see in the picture, the oxygen molecule is getting attached to the iron through donation of the lone pair, and thus it is getting attached to the hemoglobin, and this hemoglobin can transport the oxygen molecule from inside our body, from lungs to all those cells where it is required to be delivered. So you can see the unique feature of the metal ion, which can really activate a non polar molecule like oxygen to get attached to the metal center and to be delivered into those cells where glucose is to be burned and we need to get the energy. Now there are some interesting phenomena. I am not going into details of it. As we know that carbon monoxide is very much toxic, and this happens because carbon monoxide molecule can replace this oxygen and get attached to the hemoglobin. And whenever there is any fire incidents, we used to see that many people, sometimes they die because of asphyxia, because there are not enough oxygen available in the atmosphere. When things are burning, it is burning incompletely, it is producing a lot of carbon monoxide, and those people who are trapped in those buildings, unfortunately they inhale lot of carbon monoxide inside the body, and it gets attached to the iron center, and then it is more strongly binds the iron center and it does not allow the oxygen to get bind to the iron center, and that's why it creates problem, and there happens to be asphyxia. So one small trick I just want to share with you: oxygen being a non-polar molecule that does not get easily dissolved in water, but carbon monoxide, it is composed of carbon and oxygen, and there is electronegativity difference. So carbon monoxide is a polar molecule. So if there are some kind of water source available in a fire incident, and if you can just try to soak your handkerchief in this water molecule, in water, and then you can just put it on your mouth and nose, that water molecule might absorb to some extent of carbon monoxide and it will not allow to pass the carbon monoxide inside the blood. So that might help to some extent. I am not saying that it is a absolute cure, but in such incidents or such cases, it might help a bit for those people who are unfortunately trapped into such a situation. Now I said why oxygen is important, because we need to get the energy from the glucose. So that's why oxygen is important, and that's why it needs to be transported inside our body. Likewise, we need nitrogen, because nitrogen used to form ammonium ion, and we require nitrogen in our body. It is because we know that in our body there are some genetic material. Our cells are composed of nucleus, and inside the nucleus there are chromosomes. In the chromosomes there are genes, and these genes are having DNAs, and these DNAs are very important for our cell cycle to grow. And whenever we are shedding whatever cells we are having in our body, that has a limited lifetime period, that is something like 7 to 10 years, that needs to be divided. So cells are to be divided, for that DNA is required, and all these DNA, RNA and associated proteins, they require nitrogen. because in their structure there are plenty of nitrogen atoms present, and this nitrogen can be available from the nitrogen available in the atmosphere. It is not directly available to us. Generally, there are some bacteria having some enzyme which is known as nitrogenase, having the structure of right hand side with some iron center, which can activate nitrogen molecule, and it can cleave the nitrogen molecule to generate ammonium ion, which is further oxidized to nitrate ion, and that gets assimilated into our body to produce amino acids and proteins and DNA. So this is also get activated by some metal complexes. And furthermore, this is an interesting picture, I believe. This is our mosquito. It can attack us anywhere, particularly in this time when there are a lot of mosquitoes and there are problems of dengue are also appearing nowadays. It can sit on a skin or whomsoever skin it is, and it can bite us. And whenever it bites us, we get a sense that something is biting us, and that sense goes to our central nervous system, that is maybe in brain, and then it sends the signal to our hand that there is a mosquito might be somewhere in your body, and you need to take action, whatever action you want to take, I don't know, whatever it is. So in a fraction of second or picosecond or millisecond or something like that, you understand that there is a mosquito somewhere in our body and you need to take action for that. So the question is how this kind of signals goes into our brain and how we react. Now here also there is importance of the nerve centers, or these are the pictures of the neuron cells, where are the nerve cells inside our body, and how this information goes from our particular that place of the body to the brain and it comes back. There is a, in the nerve cell also there is some kind of membrane available, and in those membranes there are certain pumps which are called sodium potassium ion pumps. Now pumps mean, we know that water pump, that is really pushing water from one place to the other place. Now in this sodium potassium ion pump you can see it exists in the cell membrane. The cell membrane is nothing but a bilayer of lipid, and inside that bilayer of lipid there is this pump. This pump you can see in the picture, the downside, it is generally opens inside of the cell, and it can take up two sodium ion from here, sorry, three sodium ions from inside of the cell, and then in one ATP molecule which is called as energy currency, that used to push these sodium ions, three sodium ions, from inside cell to the outside of the cell. In the second picture you can see the three sodium ions are released in the outside of the cell, and when these three sodium ions are released outside of the cell against the concentration of the ion gradient, two potassium ion, which are shown as oval shaped ion, comes inside the sodium potassium pump, and it goes inside the cell again. So whatever is happening is that three sodium ion is going from inside to outside, and two potassium ion is coming from outside to inside. So it is generating some kind of unbalance or imbalance in ionic distribution. So there will be always excess amount of a positive ion outside the cell and less amount of positive ion inside the cell. And whenever anything happens like mosquito bite, suddenly there is a diffusion of the ions to go back to the original neutral situation. And whenever this flux of ion happening from outside to the inside of the cell, it is generating an electrical pulse. And that electrical pulse is sending the signal to our brain or our central nervous system that there is a mosquito somewhere in our body and we need to take action. So you can understand these alkali metal ions are also important to send the nerve signals inside our body. Now, furthermore, why metal ions are important in our body? This is the picture which shows that how the protein gets synthesized inside our body. You know, there are 20 basic essential amino acids inside our body that gets joined with each other to make peptides, and these peptides are joined further to make proteins which are very complicated in structure. Generally this happens by condensation of amino acids. Amino acids are having one amino group or NH2 group, which you can see here, and a carboxylic acid group, which is here. Now this amine group and this carboxylic acid group, they condense with each other and they form peptidic bond like this, and water gets eliminated, and the whole process you get a protein. Now what is happening is that whenever we are taking food, either it could be in terms of whatever vegetables we are taking, these are having long chains of proteins, and these proteins, when going to our digestive system, they cannot be digested directly. It has to be fragmented, which is called catabolism. That means a long chain of protein needs to be fragmented in smaller peptides so that our digestive system can assimilate those peptides. Now to assimilate or to fragment these proteins, you require catalyst because it cannot be fragmented directly. Either you require acid or base catalyst. Though our gastric juice is acidic in nature, but the acidity is not that much so that it can degrade the protein in that way. So you need some other kind of catalyst. And the digestive juice, whatever we are having, that is acidic, but we have a limitation. The limitation is that we cannot increase the temperature to make the reaction happen in our body. We need to maintain our body temperature. So we need some kind of catalyst which can help to fragment these proteins even at room temperature. And nature has developed some kind of zinc containing metalloenzyme. The structure you see in the right hand side in the lower part, it's a zinc complex and getting attached to certain biomolecules, and it can act as a catalyst to break down these proteins to smaller fragments like peptide, and our digestive system can assimilate this peptide and send them to wherever it is required. So these kind of things are happening 24 into 7 again inside our body, and these kind of metal enzymes are reactive inside our body to degrade whatever food we are taking inside our body and to degrade that. Now this is about mostly why the metal ions are imperative. More or less this is an overview I have given. Now I would like to tell you a small story about Barnett Rosenberg. Um, he is from Michigan State University. He is not a chemist, he is a biophysicist, and he was making some kind of experiment to see what is the effect of cell growth on bacteria if we pass some kind of electrical signals or electrical potentials across these bacteria. So he was doing some experiment on that the growth of bacteria in a particular medium where there are electrical field is getting operated. So he was having an experiment like that in 1969, where there is a particular system has been taken where the bacteria has been cultured in the media, and there are two electrodes of platinum electrodes, and he was passing electricity through the media. And for electrolyte, he has taken ammonium chloride as an electrolyte to conduct electricity. And what he has seen to his surprise, that there is no cell division occurring to the E. coli bacteria. Rather, the E. coli bacteria is getting elongated, and it is called filamentous growth of bacteria. Now this filamentous growth of bacteria indicates that there is some kind of inhibition of cell division. So he understood that something is happening. He first thought that it is might be because of the electrical field, the cell division has been stopped. So he was trying to find out what was the actual reason why the cell division has been stopped and the bacteria are growing in a filamentous way. And after 2 years of research, he realized that as he was using some kind of platinum electrodes and ammonium chloride electrolyte, it is making a particular metal complex which are known as cisplatin, which is having one platinum ion in, and which is ligated with two chloride ligand and two ammonia ligand. And this cisplatin, by chance formation of cisplatin, is really inhibiting the cell division. So it came to in his mind that if this cisplatin can stop the cell division, it can be utilized as the medicine for cancer. Now, what is cancer? We know in the cancer, generally what happens is that cancerous cells that used to grow abnormally, okay, generally in our biological systems there are certain checks and balances. Whenever there is some kind of wound, the wound gets healed over the time, the cells are replaced. But when the cells are replaced properly, then there are some kind of signals getting generated which are telling that enough cells have been replaced, you don't need to divide any more cells, and you don't need extra growth. Now, whenever these checks and balances does not work properly, then we have cancers. That is the unchecked growth and cell division of certain cells. And this happens because the genes, whatever we are having in those cells, they get damaged, they get mutated, and these checks and balances and the signals that please don't grow any more cells, that is not occurring properly. Now, how this genetic change might happen? It might happen because of certain reasons. It is associated with lifestyles. Sometimes it is because of UV radiation, sometimes for smoking. It could be hereditary also sometimes, or some viruses or some chemicals. They can create some change in our mutation in our genes, which are there in our cells. And that really induce the cancer inside our body. Now, if that cisplatin molecule that can stop cell division, so if there is a cancer patient which is abnormally growth has been found, so that cisplatin can be utilized as a medicine. So, lot of research was going on regarding that, and this is about the left hand side structure talks about the cell cycle progression. Whenever there is one cell and it needs to be divided in stepwise manner, generally first there happens the DNA replication, and then there is the translation and transcription, and then the cells get divided through the mitosis and two daughter cells appears, and the whole process go through certain cycles which are known as, if you look at this, the left hand cycle, it starts with a growth and normal metabolic roles. It generally there is nothing happening at that phase really. Then the DNA replication, the synthesis phase, then the gap 2 phase where the cells check that whatever DNA has been replicated, whether they are proper or there is something wrong with that. If the cell is satisfied that DNAs have been copied properly, then it goes through the mitotic phase change like prophase, metaphase and all, and it gives two daughter cells. So whenever we are trying to uh, cure a patient with cancer, generally there are different approaches. The first approach is do surgery, remove the tumor. The second approach is chemotherapy, that is use those chemicals inside the body which can turn off the cell cycle. To turn off the cell cycle, it can block or turn off signals that tell the cells or cancer cells to grow. So there are certain kind of system inside our body which tells the cells to grow, and if we can switch off those signals, it can really stops the cell, or it can prevent the cells from living longer than normal, and it can destroy the cancer cells, and it can stop the cells to allow to grow further. Now, I was talking about cisplatin, the platinum complex. So the scientists tried to see where this platinum drug is going inside the body and how it is interacting. So inside our body, there are various biomolecules. There are RNAs, ribonucleic acid, which generally helps in copying the genetic information from DNA. and we have DNA, and we have several proteins, and scientists used to check that where the platinum is going, and they found that primarily the platinum are getting accumulated in DNA. So it is must be interacting with the DNA, and that's why the cell cycle progression is getting stopped. Now, if you look at the structure of the DNA, it has been proposed by Watson and Crick. You know, they got Nobel Prize in 1962. This helical structure, double helical structure, and it is composed of three parts. One is called a pentose sugar, and there are phosphate ions. You can see the phosphate ions are really phosphate ions are making bridge between the pentose sugar, and there are some nucleobases. So there are 4 nucleobases, and the sequence of these nucleobases are the key about the sequence of the genome, and there the life, how the life of a living being will be, what will be the characteristics, that is encoded in this sequence of the nucleobases. So these nucleobases are adenine, cytosine, guanine, and thymine. So as I said that cisplatin is going into DNA, so what is happening is that cisplatin, when it is getting inside the cell, first it is getting hydrolyzed. One of the chloride ion is going away from the coordination sphere, and water molecule replace that chloride, and then the second chloride ion is also replaced by water molecule, and then these platinum complex with 2 water molecules, they are cationically charged now, and DNAs are generally anionic in nature. There is electrostatic sort of interaction. So platinum complex goes close to the DNA, and the DNA nucleobase guanine gets attached to the platinum. Because of this kind of interaction between the guanine and platinum complex, the structure of the DNA gets destabilized, and whenever there is signal that you divide the cell, so the DNA copying mechanism gets activated. But when the DNA is copied, it is copied in a faulty way because there are already platinum complex inside. So the structure of the DNA has been disturbed. And when the cell starts to check that the copied DNA are proper or not, they find that these DNAs are faulty in nature, and these are faulty. So it is rejected, and the cell cycle stops, and it goes to the G0 phase, which is called cell cycle arrest. That means it does not allow the cell to grow or divide further, and that's the way generally it stops the cell growth. So this platinum DNA adduct is very, very important for stopping the cell growth or to act as an anti-cancer agent. Now, this cisplatin complex has several problems as well. Those problems are side effects, because this platinum complex, they used to, as I said, that platinum is not an ion which is chosen naturally, because it used to interact with various other enzymes inside the body. So whenever a patient is treated with cisplatin, it starts to give problem like nausea, like problem in kidney, problem number of cells get diminished, and ototoxicity, that is the hearing problem, and the cell sometimes get acquired resistance, that is that does not, the cisplatin does not work properly after certain time. So whenever chemotherapy is given to the patients, many a time they are put on several different chemotherapeutic agent, so that the acquired resistance does not grow inside the body. Now, as cisplatin has shown effectiveness as anti-cancer agent, lot of other platinum complexes have been researched and found out which can be utilized as anti-cancer agent. And after a lot of tests, because you know that every vaccine or every whatever medicines are coming up, they has to go through certain clinical trials. So after a lot of trials, it has been found that there are 6 more platinum complexes, 5 more platinum complexes: carboplatin, oxaliplatin, niraplatin, lovaplatin, heptaplatin. They can be utilized as anti-cancer drug, and sometimes they used to show less side effects, so that can be utilized very well. Now, go to the next slide. As I said that the platinum complexes are generally making interaction with the DNA. So we can try to find out other metal complexes which can interact with other proteins of the tumor cells, so that it can be known that that can stop the cell growth, because it is not only the DNA, it is also the proteins which are also important for the cell growth progression. And there are certain proteins which can be inhibited and that can be utilized as anti-cancer agent as well. So a lot of research is going on some other metal complexes, and it has been found there are some ruthenium complexes, which you can see the structure. I am not going into details into it, but what I can say is that the first complex is in clinical trial right now. First two complex, they are active against primary tumors, and the second one is active against metastatic tumor. You know, metastasis of cancer is very, very dangerous. It is because when the primary tumor, the some of the cancerous cells leaks into our bloodstream, and it can be transported to some other part of the body, and it can get stabilized over there, and in this way cancer can get spread. So to stop this metastasizing, some metal complexes have been getting tested right now under clinical trial, and these ruthenium complexes you may see in near future come up as a chemotherapeutic agent to treat the cancer patient. Now, I just want to go to another kind of illness which is called rheumatoid arthritis. You know, this is a basically illness for the joints like knee and elbow. It happens like that, it degrades the cartilage and the synovial membrane which is there present in those joints, they get swollen. And this is kind of a disease where the body mistakenly attack its own joint tissues. So the body feels like that there is something wrong inside these joint tissues, and they start to attack and destroy these joint tissues. Okay, so the first stage is the body attacks its own joint tissue. In the second stage, the body makes the antibodies and the joint starts to swelling up. And in the third stage, the joints become bent and deformed. And in the last stage, if not treated properly, the disease can progress to the last stage and there is no joint left at all inside the knee or the elbow. So this is another very difficult problem to manage with, and it has been found certain gold complex, as I said earlier, that this again is not a natural choice, but this gold complex can inhibit certain enzyme which is making such kind of enzymes activated and attacking its own joints. So this gold sodium thiomalate or gold thioglucose or auronafin, they can be utilized as medicine for this arthritis. What happens in these cases is that it inhibits certain enzymes which get secreted from lysosome. So the gold goes there and it inhibits those enzymes to react with our joints, and this gold gets accumulated here and forming a certain kind of entity which are known as orosomes, and it stops this enzymatic activity, and the sulfur present in the enzyme gets coordinated to the gold, and it does not allow the enzymes to react upon on our joints, and in this way it really helps us to prevent this kind of disease inside our body. Now I am going to another aspect which is called metals in diagnosis. This is a picture of X-ray. Whenever we fall ill, generally you go to the doctor and they ask for certain pathological test. It could be blood test, and if they feel like that there are certain organs inside our body which is not working properly, they can say that they can take a picture of those particular organs. So if there is some problem with our bones, it is recommended to do the X-ray to check if the bones are okay. This is ultrasonography, that also to take picture of certain organs inside our body. This machine could be MRI or CT scan. CT scan is three-dimensional X-ray, and MRI is a particular process depending upon the magnetic resonance. It also takes the picture of our organ inside the body and in a three-dimensional manner. And if you take the picture. The first one is the CT scan and the second one is the MRI structure. And these are all the pictures taken from the outside of the body. So it is very difficult to sometimes to understand what is going on inside those organs. So it is assumed that if we can manage to send some kind of spy inside our body to those organs, which can get absorbed in those organs, and they will give the signal from those organs that what is happening in those organs, and we can detect a signal from the outside of the body, then even without any operation or anything, we can understand what is wrong with those cells on those particular organs. So for diagnosis, apart from taking picture from the outside of the body, the scientists have thought that if we can utilize certain radionuclide which emits alpha particle, beta particle, or gamma ray, and if those radio particles can go inside the body in that particular organ there is where there is some problem, they can send the signal from there, and we can detect the signal from the outside, and we can see what's going on inside these organs. But there are certain limitations. The limitations is that most of the radionuclide, it emits alpha particle or beta particle. Alpha particle and beta particle has some kind of mass, and if you put those radionuclide inside the body, it can create problem because it can interact with our tissues and it can destroy certain proteins and tissues. So that cannot be utilized. We need to focus on certain radionuclide which is going to send signal through gamma ray. Gamma ray pass through the body, it does not have any kind of mass, so it does not interact in that much, and the energy of the gamma ray should not be very high. In that case, again, it can create problems. So they have found there is one particular radionuclide which is called technetium 99M technetium. It is M because it is a metastable state which can be incorporated inside the body, which can be guided to that particular organ where we want to take the information, and it can get absorbed in that organ like heart or lungs or thyroid or kidney, and it can send signal or picture of that particular portion. Okay, this is the picture of that radionuclide SPECT tomography scan, and which can give us the idea about the situation of the heart from both outside and inside. So in a non-invasive manner, these metal ions, which are radionuclide in nature, can send the signal and can help us to give the information about particular organs which are deeply seated inside our body. Now, there is one more example just I want to talk about. This is about, again, ruthenium. We have heard about nanoparticles, and we have also heard about nanoparticles have some unique feature that it can really show some kind of absorptivity because it's porous in nature and its properties are something different. It is known that ruthenium nanoparticle, they can be utilized for photothermal agent. Now, photothermal agent is something which is new. That is, whenever there is a cancer patient and there is some kind of growth inside the body, you can send some photothermal agent. That means it can absorb light and it can get heated up. And when it gets heated up, it starts to destroy the cell surrounding where it is absorbed. So this is called hyperthermia. So ruthenium nanoparticle is utilized along with one ruthenium complex, which is known as ruthenium bipyridyl complex. You can see the structure in the right hand side downside, and these ruthenium bipyridyl complex can capture light, and it can generate reactive oxygen species, and that can destroy the cancerous cells. So what happens is that altogether these ruthenium nanoparticle and ruthenium complex, they are combined together through some kind of other polymers, and they can be delivered. This polymers is called NEPAM, which is thermal responding polymers, which used to dissolve at higher temperature, which is solid in low temperature, but if you heat it up, it dissolves. So what happens is that this polymer is coated with ruthenium nanoparticle and ruthenium complex, and it gets delivered on that particular tumor tissues, and then it is heated up by some kind of light activation. So these polymer gets dissolved. Ruthenium nanoparticle becomes exposed. Ruthenium complex gets exposed, and both of them starts to act upon on those tumor, and it starts to show the thermal image of that particular organ. So you can see the thermal image, that is the lungs of a particular mouse which is heated up, and you can scan that image from the outside, and you can understand that where the tumor is and how it is getting reacted with this ruthenium nanoparticle and ruthenium complex. In the next picture, I just want to tell you to focus on the right hand upside picture. It gives a three-dimensional structure of the tumor which is deeply seated inside a mouse, and this thermal imaging can tell us what is the dimension of the tumor actually, and that can help us to diagnose that particular tumor inside the body. One more important aspect which is coming out nowadays, which is called drug delivery. Drug delivery, you need some delivering agent, because whenever you are injecting drugs inside the body, it can go at any place of the body and it starts reacting with several other biomolecules inside the body. But if you have a proper drug delivery agent like pizza delivery boy, he knows where to deliver the drug. And for a drug delivery agent, something must be porous in nature so that drug can be loaded inside. It should be stable in biological fluid, and it must deliver the drug in right address. So what happens is that, as I said, that metal complexes in presence of certain ligands, they can make certain compounds which are known as metal organic framework. It is composed of the metals and organic ligands, and generally the organic ligands bridge between different metal ions, and there are some porous nature, and in these pores you can load certain drug, and such a metal organic framework is known as ZIF90. It is composed of zinc ion and some aldehyde, imidazole aldehyde, and it is porous in nature, and this is utilized to load certain proteins, which proteins can really get delivered inside that particular tumor tissue or where the cells are infected, and then these proteins can really work out the problems by somehow reacting with the antigens. And this is very advanced stage of research right now going on, how to load certain proteins which can be utilized as drug inside this metal organic framework. And this is known as CRISPR technology, which is just getting generated in last 10 years and so, which is still in the stage of infancy, but in future definitely this is going to help us in treat certain diseases. In the last part, I want to tell you something about the immunity. We are hearing a lot about immunity right now because of this COVID attack. We have a natural immune system. We have some NK cell inside our body, which is called natural killer cells, which usually patrol our body every day and night. And if they find anything like any antigen is coming up, it works upon on that. Apart from that, we have certain cells known as T cells and B cells, which some of them acts inside the cells, and some of them acts outside the cell, and they react with the antigens and creates antibody. They are antibody basically, and then they kills those infections or antigens. Though some research work has been done by these two gentlemen, James Allison and Tazuku Honzo, on our immune system, and they got Nobel Prize in 2018 in medicine, and they got the Nobel Prize for their discovery of cancer therapy by inhibition of negative immunoregulation. What does it mean by negative immunoregulation? It means that as we have our immunity system, again in the immunity system there are some checks and balances. That is, the immunity system is used to signal how much immunity cells needs to be grown. it should not grow up to a certain amount, because if it grows indefinitely, then it will attack our own body. So these checks and balances are there, that how much immune cells needs to be grown while some infection is there inside our body. So what happens is that they assumed, or they proposed, that if a patient is not recovering well, if we can somehow bring down the checks and balances of immunity system, then our immune system becomes more aggressive and it starts to produce more and more antibody. And in that case, if the patient, there is a chance, huge chance, that our natural immunity can be good enough for the recovery of the patient. One such experiment has been done with oxaliplatin for cancerous patient. You can see in the left hand side, this is a immunocompetent patient who have his immunity. In that case, you can see when you are using oxaliplatin along with its immunoresponse, the oxaliplatin acting is a very good drug, and the tumor volume is getting decreased with the time with respect to untreated patient. But when, if there is some kind of model system where the immunity system has been taken off, then we have found that if immunity system is not working in that patient, then oxaliplatin also cannot work. That means some of the molecules which are getting generated as drug, they can work wonder along with our immunity system. And if required, if we can somehow bring down the checks and balances of our immunity system, it can help us to fight with the antigens like whatever happening this coronavirus, and it might help us to get recovered even being treated with external medicines. But again, I am telling, these research are in the forefront of our advanced research, but this has to be translated into product somewhere down the line, but it is yet to be done. And we hope that these new ideas and new informations will give us new handle or new warhead, so that we can really fight with this kind of viral infection in our future. So to conclude, this whatever has been started with the generation of cisplatin by Rosenberg, in last 50 years, the field of this biological application of metal complexes have been matured a lot, and new improved medicines have been come up, and 10 more compounds, apart from whatever I have shown, there are 10 more compounds are now in different phase of clinical trial for cancer therapy. And recent research show prominent scope for diagnosis through fluorescence, and metal organic framework can act wonder to deliver drug like proteins inside the body. And effect of application of metal or drugs and immune response can be explored further for more efficient treatment. With that, I would like to acknowledge my institute, which helps us to give me the resources to give you this particular presentation. So this is IIT Indore. If you have not visited, so in near future, when the COVID pandemic goes away, you are invited at any time. You can come over. A beautiful campus is coming up. And thank you very much to all of you for your kind attention. Thanks.
Thank you, sir, for this enlightening session and sharing wonderful information with all of us. Again, I request Dr. Tabinandan Joshi to have question answer session with our resource person, and participants can put their questions in chat box. Please, sir.
Thank you, madam. Thank you, sir, for this enlightening session. So we have some general questions regarding this topic.
Yes.
So the first question is, how are people exposed to metals, and which metal is responsible for disease?
Well, as I said, that as I have shown this biological periodic table. So whatever you can see in this biological periodic table is that apart from those which are in the green box, all the other elements are toxic for our body. Okay, all the other elements are toxic for our body, but we can utilize it in certain way, so that if the benefit is more than the toxicity, then we can utilize and handle it with care, and it would be beneficial for us for diagnosis and treatment.
Yes, sir. Thank you. The next question that you have shown in that baking soda is useful or not?
Well, baking soda definitely it is useful for making certain bakery products, I think. Okay. In our case, generally, if we have acidity, sometimes it is because baking soda is basically basic in nature. Okay, so sometimes in some medicines there are a component of baking soda to some extent to treat the acidity, but that is not for a very that is a what I can say, that is for a temporary relief, but it is not a cure for any disease as such, because you know this acidity is not a, this is a symptom, this is not a disease. Okay, so to alleviate that symptom you can utilize.
Okay. The next question will be like that. How do we identify that we are having heavy metals in our body, and what are the symptoms?
Mm, well, there are various symptoms for various metal ions. Okay, even those metal ions, if they are in excess, it can create some kind of problem. Okay, so depending on like arsenic, you see it causes some kind of rashes in your hand and feet and all these things. So it depends upon on what kind of symptoms you are getting, and depending upon that the doctor can prescribe some kind of blood test, and from there it can be detected that which heavy metal ion is there inside the body.
Uh, we are getting question in the chat box also.
Yes.
Uh, does turmeric remove heavy metals from the body?
Well, turmeric, it can act as a ligand and it can bind as a bind to the metals. That is true, but it cannot really remove, because whenever you are trying to remove a metal ion from the body, you require to make a water soluble complex. Now, turmeric does not make water soluble complex mostly. It is itself is not that much water soluble. The water solubility is very low. So I don't think turmeric can really, it can definitely it can enhance our immune response, but to remove the heavy metals from our body, you need ligands like EDTA, which will chelate and make water soluble complex, and it can be thrown away from our body through kidney.
So as per the time, we will take the last question.
Yes.
It is regarding RO water.
Yes.
Is RO water is good for health or not?
I think, I don't know, I cannot comment on good or bad, but it is safe. That is what I can say, because many diseases are waterborne, particularly like jaundice and typhoid. They are waterborne, and many times people get infected because of drinking of contaminated water. Okay, so RO water is at least recommended that it can eliminate those kind of viruses which exist in water. So but of course you need to check the TDS, because certain amount of minerals are always required in the water, like calcium and magnesium for sustaining our body. So a balance is required always. So if you are drinking RO water, that is good for you are safe, that I can say, but for whether it is good or not, you have to keep checking your TDS, I think.
Thank you, sir, for your reply. I think we will stop the question answer
Okay,
session here.
fine.
Madam, please continue.
Thank you, sir. Thank you, sir, for your all responses. I'm sure everyone is benefited by this informative webinar. Now to conclude, I invite Dr. Arvind Jain, Head of Science Department, to propose a formal vote of thanks. Sir,
Sir, please
please.
stop sharing your screen.
Yes, yes.
Okay, thank you, Sejal Madam. Honorable Director, Reverend Father Simon Raj, respected Principal, Dr. Sister Alice Thomas, respected resource person, Professor Suman Mukhopadhyay, all my dear colleagues and participants. Good afternoon to all. I, Dr. Arvind Jain, delighted to propose a vote of thanks on behalf of Department of Science, St. Paul Institute of Professional Studies, Indore. on this platform of our national webinar. Firstly, I am thankful to our today's resource person, Professor Suman Mukhopadhyay, for his insightful lecture on the topic metals in healthcare, which was full of wisdom and information. Once again, I thank you, sir, for honoring us with your presence. I extend a sincere thanks to our director, Reverend Father Simon Raj, and Principal Dr. Sister Alice Thomas for providing us this wonderful opportunity to organize this webinar. A very special thanks to all the participants for being a great audience. And I would like to thank my team, Dr. Tavindan Joshi, Professor Sejal Gupta, and Professor Ankur Sodan for their coordination and support. Thank you all.
Thank you, Arvind sir. Thank you, Suman sir. Now this is a general announcement for all the participants that feedback form link will be provided in WhatsApp group as well as on the mail ID. So please feel the same. Thank you, sir. Thank you so much.
Thank you. Thank you very much.
Sir, thank you. Thank you very much, sir.
Thank you.
Thank you, sir.
Add करूं?
And
Yes. Done, madam?
डन हो गया. मैं बस देख रही हूँ रिकॉर्डिंग कहाँ सेव हुई है.
Sure.
ठीक है सर.
Okay, thank you. Thank you very
हाँ
much.
सर.
Yeah.
मानो एक मोबाइल दे दो. मानो दे बेटा मोबाइल जल्दी. दे दे दे.